Okay, so now it's time to talk about the last part, or the second part of AP Calculus 9.4, and that's actually dealing with limits and differentiation of vector valued functions. So remember, a vector value function has an I and a j in it, and the x part will be going with the I, and it'll be defined by a function of time, because it's going to be a parametric function, plus another function that gives us the y value, and it'll be put with j. And a lot of times we might say r of t equals this, or some other letter. And so that is a vector valued function. We looked at that in the last video on AP 9.4a. This is AP 9.4b. And so 4 basic ideas, and honestly, none of them are very difficult. The hardest part about 9.4, and really, in my opinion, everything about vector valued functions, is just making sure that you understand how vectors work to begin with. And that was the last video, AP 9.4a. So here we go. To find the limit, so we're going to start with limits. To find the limit of a vector valued function, you want to find the limit of each part, so the I part and the j part. And then if either part's limit does not exist, then the limit for the entire function does not exist. So say you're taking the limit, the I part, and you get 4. The limit, the j part, though, is infinity. It does not exist. So you don't just say, you don't give the limit, the I part, and ignore the j part. You just say the entire vector valued function, the limit doesn't exist. Now, whenever the limit does exist for each part, write your answer for each part with each part. So for example, if the limit of I is 4, you're going to drop a 4 in front of the I. You're going to say the limit as x approaches whatever, or as t approaches something, of r of t is, and then you say, if the limit for I is 4, you put it in front of the I, and if the limit of j is 2, put it in front of the j. No big deal, pretty intuitive there. Just some pretty basic calculus limit stuff. Nothing crazy. All right, number 2. So just like a regular function, a vector valued function is continuous at a point C if the limit as the function approaches C equals the value of the function at C. So pretty much your same limit rules, your continuity rules for functions apply to limits as well. And so just go through your continuity tests and make sure that it works for I and j, and you're good. All right, differentiating is also just as simple and intuitive as you might expect. Just differentiate each part separately, and then write your answers with the I and your answer with the j. No big deal. It's pretty straightforward. Really, the only thing that is just a little weird, and it's not calculus that's weird, it's the vectors that's weird, and that's number 4 here. Note that if you're going to take the derivative of 2 separate vector valued functions multiplied together, well, first of all, you're going to have to use the product property. So the derivative of, well, let's not use f, because that might confuse you, because I've already been using f. Let's use s and q. No, how about, yeah. So the derivative of the first vector value function times the second one plus the first one times the derivative of the second. So you know how the product property works whenever you are going to take the derivative of things multiplied together. But here's the thing to note, though, and this is where it gets a little weird. Since these will both be vector valued functions, then whenever you multiply each of these together, you're going to end up using the dot product, which is going to get you a scalar plus another scalar. And so then your final answer is going to be a scalar, just a regular number. It's not going to be another vector. So there you go. That's the gist of it. And so good luck.